Hello there, Vicki Gaines here, and this is linear regression making predictions, interpolation, and extrapolation. Let's learn something new. Learning intentions. The students can use a given line of best fit to estimate values for a given situation. Students can find a linear regression model for a given set of bivariate data. The students can use a linear regression model to make predictions. And students can distinguish between interpolation and extrapolation and explain the difference. Terminology. Interpolation is a process of estimating a value between given observations of data. So there's the data graph there. And if we're within that range of X values, then when we do a prediction, that's called interpolation. Extrapolation is a process of estimating a value beyond the distinct range of the given variable based on its relationship with another variable. Making predictions from graphs, example 1. The scatter plot shows the relationship between the age of a driver and the number of miles driven each year. Based on the line of best fit, predict the age of a person who drives 13,000 miles in 1 year. So we have to decide if this is interpolation, and that range right there is where the data is. If we are using an X or Y value within that range, then that would be interpolation. Extrapolation is going beyond that. Let's see. We are beyond the interpolation. If we do 13,000 miles, it's about there, and go to the line and go down, we can estimate that the person who drives 13,000 miles in 1 year is about 30 years old. And we already mentioned it's extrapolation because it is beyond the range of the original data. Example number 2. Scatterplot shows the relationship between the number of days absent and a student's final grade in a course. Based on the line of best fit, predict the final grade for a student who has been absent 12 days. So there is the range of values that our data is in, and we have to see if the 12 days is inside there or not. So there's 12, and it looks like it's outside of our data. The predicted final grade for a student who has been absent 12 days is about 80%. So it is extrapolation again, because being absent 12 days is outside of the original data set, which has X values between 0 and 10. Using regression equations to make predictions, this is example 3. Prediction values are meaningful only for X values in or close to the range of the data. The X values in the original data set, because we don't see the actual data, so they're telling us it's from 0.9 to 4.9. So it would not be appropriate to use the regression line, and that's Y hat, because we are going to use it to make predictions. So it's not actual data, it is a predicted value based on the linear regression equation, which is 196.152x plus 102.289 to predict carbon dioxide emissions for gross domestic products such as 0.2 or $14.5 trillion. The regression equation for the gross domestic product is actually in trillions of dollars, and the carbon dioxide emissions is in millions of metric tons. There is the regression equation again. So we're going to use that to predict the expected carbon dioxide emissions, the Y had for the following gross domestic products, which is our X, show all work, write a prediction statement, which is already there. You just have to fill in the blank using a complete sentence. So we're using the 1.2 and we're plugging into our linear regression equation, and then just put that in your calculator. Calculate that amount, and we get about, because we do any rounding for linear regression to 3 decimal places, 337.671 million metric tons, and that's what fills in the blank. Next time, we're using the same linear regression equation, but we're plugging in the $2.0 trillion. And trillion dollars, we're not adding all those zeros on because the formula is based on trillions of dollars. So we're just putting in place of X the 2.0 and then calculate. We get about 494.593 million metric tons and fill in your answer in the blank. Do it one more time with $2.5 trillion. So in place of X, we're putting our 2.5. We put that in our calculator to calculate, and we get about 592.669 million metric tons and fill in your blank with the same answer. Example 4 is square footages in home sale prices. The square footages and sale prices in thousands of dollars of 7 homes is in the table there. We need to put that data into Desmo's graphing calculator. So put all the X's in X and all the Y's in the Y, and we can get our linear regression equation. Remember, we round to 3 decimal places, and it is there on the screen that's what we're going to do. We get 0. Y hat, because we're using it to estimate, is 0.123x minus 50.030. We're going to use that to make predictions. It says find the linear regression equation, which we've done. Use the model to estimate the sale prices for homes with the given square footage for each situation. State whether it's interpolation or extrapolation and give your answer in dollars, not using thousands of dollars, and show all work. So we have our linear regression equation, and the first time we're plugging in 1,450 square feet. And if you look up at your data, that is within the range of the original X's. So this will be interpolation. Let's plug in our X value and calculate. And remember, that's in thousands. So we need to move that decimal place over 3 times. So 128,320, and it's interpolation. If you look at B, it's 2,720 square feet, which is beyond the X values that are in the table. So it'll be extrapolation. Let's substitute in to our equation and calculate. Use your calculator to get the values, and the formula gives it in thousands, and we need to make it without the word thousands. So $284,530, and that's extrapolation. Number, or part C, excuse me, is within the range of values that we have up there. So it'll be interpolation. So we use our linear regression equation. We plug in the 2,175 square feet. We get our answer in thousands and then move our decimal place 3 places. So it's $217,495, and that's interpolation. We have now completed making predictions, interpolation, extrapolation. Vicki Gaines, hoping you learned something new.